Hello, I'm Harrison.
Hey, Harrison. My name is Don Presnell. All right.
Nice to meet you. Right. So what keeps you busy?
My business. It's a lot of books. It's a lot of correction that needs to take place in my business. As far as customers, I have a lot of
When you
policies.
say corrections, like what do you do?
Well, what I do is I am an Allstate Agent, and I opened up an agency on July 1st, and then 3 months later, I bought another book of business that increased the size of my business for a couple of folds. So what I do is I sell a lot of policies to a lot of folks. I service the community. In addition to that, I own an IT company called TCG, the Collins Group. And what I do is provide consultation to a lot of hedge funds on Wall Street. I provide them consultations on IT infrastructure globally. That's what I do.
When you say IT infrastructure, what does that mean?
Well, it means the network that you see. I know a lot of people are used to seeing binary code, but nobody knows the archetypes, the architecture behind that. Undersea cables,
what kind
satellites.
of architecture?
Well, we're talking about Ethernet, VPN, MPLS, all of that stuff.
Okay, so I'm kind of confused.
You're kind of confused. Okay, well, let me try to explain it to you a little bit further. Well, what it is IT infrastructure. The things that most people don't realize about infrastructure, it's all about the routers, well, the hardware, the undersea cables, the transmission devices, mediums, like copper, fiber optics, undersea cables, private lines, satellite. Then you have the hardware, which is going to be the routers, the switches, things of that sort. Multiplexing devices. I know all of that.
So you were the guy that goes in and you...
Stop you?
So...
You're doing good.
I'm sorry.
I'm the one that's hot. Out of the chicken lights. Go ahead.
I'm sorry, I don't really know.
Well, you know how you get on the computer. On the computer, what you see is, okay, I see my applications. I see the windows that open up.
Yeah.
But how do you transfer the data, the things that you want to communicate to another user, or if you want to obtain data from a server, you say, okay, I'm going to go to Google. I'm going to extract this data from Google. And you say, okay, my search, well, say for instance, you go to Google and you pull up a search engine and you go in and you put in, okay, let me look up something on a certain animal, like a rhinoceros. How do you get that information? How does it come back from you from the server? Well, it has to be encapsulated. It comes
What's
in.
Encapsulated?
Encapsulated means it's going to be, they're going to put like a package around it. They're going to put some like some identifiers that helps identify you, like the IP address, from the person you're asking and you're requesting the information from. So we encapsulate that data. It can't all fit into one package. So we chop it up in little bits and put them in frames, or if not, cells, and then it transfers back to you. And you get it in binary, in ones and zeros. The binary is created whether you're looking at fiber optics or you're looking at copper. You can use electrical impulses or you can use light sources. All you do is fluctuate the light sources if you use them fiber.
Fluctuate mean?
Fluctuate means turn it on, turn it off. And you flick the light on, you get a 1. If you turn it off, you get a 0. Okay, if you go with copper and using electricity, only thing you do is you turn electricity on, you get a 1. You turn it off, you get a 0. And that gives you your 1 and your zeros. It's nothing but a logic state machine. Only thing you're doing is transferring that data in ones and zeros in several different types and forms, and that gives you your message. And then when you get back, it interprets that. Whatever systems or technologies that you use that overlay on the technology, what it's going to do is it's going to interpret it for you. So what you get in the end result is whatever you're looking for.
So, I don't know if you'll know this, but how do you get it within milliseconds of your search?
Well, you get it because it transfers in smaller bits. They transfer frames. When you see a frame can be 4,000 and some different bytes. But a cell is easy to transfer cells, which are fixed size, 53 bytes in length. And they transfer through the system that way.
How does it go from the system into the, like,
IP
what you search?
IP addresses, identify the source from the destination, and then the other part of it is you have switches that can switch frames and packets faster than a router. A router pays attention, is a layer 3 device. It pays attention to the network that you're trying to deliver it to. The switch doesn't give a crap. The switch just switch large masses of data quickly as possible. That's all it does.
So, I just had a question.
Sure.
Just lost it.
Tuffy. Go ahead.
I know an IP address is like in the tab, what you type in. I know that's the IP address.
4 octets means that you got 4 groupings of 8.
And what do you mean by 4 groupings of 8?
Well, an octet means 8, but then you got 8 sections. You got 8 groups. You got 4 groups of 8. That's what it is, and that's what gives you IP address. You might see an IP address that may be the nomenclature says 132.12.8.10. You got 4 dots. You got dots. You got 132.14.12.8. That's an octet.
Oh. Who does your company work? Like, who does your company help?
Well, depending on which one. See, I have an Allstate agency. It helps the community at large get insurance, transfer their risk over to us for a dollar amount. Now, TCG is the other company that I have. It's the Collins Group. TCG is an IT company. It helps hedge funds. Those companies like you have large investors that are investing in they want to know, like say for instance, you have a company like Frontier, AT&T, Verizon. These companies are interested in buying more infrastructure, or they may be infrastructure is like, okay, people who build out wireless networks, people who are building cable systems to expand their network, to reach more homes in rural or in urban environments. What they do is they're trying to expand their market, their reach to the consumer. The FCC and the government, they get together and they say, okay, well, you know what we need to do? We need to make sure that more of the community, more people out there, no matter where they live, where they reside, we want them to be better connected. We want them to be more connected than what they are. There are some companies out there that are interested in some of the previous investments of the leaders in those industries, like the AT&T and Verizon. They're interested in trying to say, okay, well, how can we forecast what's next? How can we forecast what infrastructure is available for a smaller company to come in and make a purchase? That's why I come in. I come in and I help them figure out the health. I come in, and when I say the health of the network, the health means, okay, what level of disrepair is in? Because I worked in maintenance. I worked in support of maintenance. Like we got certain areas in Northeast, like in Verizon's territory. It used to be old Marbell. That's old infrastructure. Some of that copper that they laid down, that when I told you earlier, you can do logic state, and you can do it either in fiber optic or you can do it in electrical pulses. That's electrical pulses. When you hear copper, that means that you got a copper wire, and a copper wire, all you got to do is add electricity to it.
So do you work with circuits?
I work with everything. Everything from the, from like I say, from transistors to what you call, from transistors to receivers to multiplexers to passive state machines, and it's a plethora of devices out there that help transfer the data that you're talking about. You got companies that called Cisco. You ever heard of a company called Cisco? Not the one, the Cisco with the S and the Y, and they do food. Cisco with the C, the I, and the S and CO. That's a company that's out of California. And
the one that has in the movie Help, when she's with the Cisco to help bake the fried chicken, or?
No, that's the food.
You're thinking of Crisco.
You think Crisco. Okay, this company is, Cisco is a company, what I was referring to is you have the first company that I was using the analogy for is Cisco. That's a SYSCO. They do food. They provide food for a lot of restaurants and things, but the company I'm speaking of is short for San Francisco, which is CISCO. They are equipment manufacturers for the companies that you use your cell phones, like AT&T, Verizon, T-Mobile, Sprint. These companies provide all the equipment for large telecoms to switch and transfer data, and even for the end users to use. Even some of the phones you have, telephony devices, which is telephone and packet over IP and things of that sort. These companies provide all of that equipment for these companies, and you know every piece of equipment have what they call a mean time before failure, meaning that they may have 300,000 hours built into them before they fail. But at the same time, companies invest, like AT&T or any of the other large telecoms, they might purchase hundreds of thousands of these pieces of equipment just to do maintenance on a yearly basis, to keep up the network so that things won't fail. When customers buy, like business customers, mainly business customers, not consumers, they go in and they say, okay, you know what's the uptime for your network? That's the selling part of it. They build it into a service level agreement. The service level agreement goes to a business company that says, okay, you know what kind of guarantees are you going to have? Just think about it. If you're a Wall Street company and you're trading stocks on a daily basis and you're trading millions of dollars of money from Wall Street, you are concerned with the uptime of that network. What's built into that uptime is the mean time before failure for each device in that network, and that is the rate limiter for a lot of companies. When they sell that package to a business company, what they do is they say, okay, I can guarantee you that you won't suffer an outage but one time out of this whole year, and it will only endure for a couple of minutes or even seconds out of the year. In our network, when you mention something about SLA and you're talking about how can they transfer data within milliseconds, I had a customer, I remain nameless, they were concerned about, they had an operations in Mumbai, India, and here they had an office that was in New York, and they were concerned about their applications. Do you know how sometimes when you get on your network and you say, I'm on my computer, and every time I get on this application, I'm playing with this little particular program, and it times out on me. It never returns back. That happens. You know what it is? The application has a timeout feature on it. And depending on where the server is, where you're acquiring the data from, and who you're communicating with globally, that application can say, okay, you know what, after about 250 milliseconds, we're going to time out. This customer had a service level agreement that says, okay, we're going to get a rebate if we suffer so many timeouts, and if we got a time sensitive application that requires it can't go no further than 290 milliseconds for you to return the data on it, or it's going to time out. It's not going to work properly. Some of these people built into it, no matter what you have, no matter what type of traffic you're dealing with, you could be dealing with just data. Say, all I want is the data coming back. Give me my document. Some people might be transferring, they may have interactive video or live video. Say, for instance, you teleconferencing with someone. It has a different type of requirement for delivery. So with that delivery, you say, okay, rather than having 290 milliseconds, if it's time sensitive and it's video, it may need to be 280. Or you'll get a choppy video. You ever seen that situation, that scenario? It come you like freezing it, or you might get that old karate, old 1970s karate where they talking and then you don't hear the voice until later on. That's that playback issue that you have, and it's not delivering all the quality delivery. They call it class of service and quality of service that's built into the SLA, the service level agreement that you have. So it's a very intense type of engineering that takes place, and it deals with a lot of protocols that most people don't see behind the scenes. The only thing we are concerned with is how am I interfacing with the internet, and is it delivering what I'm asking it to deliver? There's a lot of people behind the scenes, we don't see them. It goes through undersea cables, they call them the short abbreviation. I know I've been using a lot of acronyms. TATS. I didn't introduce that one before, but that means transatlantic cable. Then you got semi-weak cables, all these things that we don't see. 95% of the traffic that you see and the servers that you're dealing with across, you might be, especially when you start considering some of the new technologies like cloud services, where everything is distributed, it's not local. You don't know where you're getting your information from. They do that to protect some of the sensitive data and intellectual property, but it's even more complex now, because what you're dealing with is now you got to think about, okay, where am I going to get this data? Where is it coming from? And how is it going to be delivered to me? And then now I got to deal with so many different, I got to accommodate so much technology and so many attributes for the data. How am I going to ensure that I'm going to get it back in a timely fashion? It's a lot of things you got to deal with when you're talking about engineers now.
So what advice would you give your 11-year-old self?
My 11-year-old self?
So if you could go back in time and talk to him right now, what would you say to him?
Take advantage of opportunities that are given to you. A lot of people don't be afraid to challenge yourself, because, you know, as a young person, if I was 11, I would focus a whole lot more on my studies in school, and I would try to just be myself, and I would concentrate. Some people think we want to try to do the easier things. Challenge yourself. Don't be afraid to fail. Don't be afraid to fail. I failed so many different times, young man, it's ridiculous. I still have some level of apprehension, even interviewing, but at the same time, I look back on some of the mistakes that I made and some of the regrets I made, and it was being fearful of failure. Don't be afraid to fail. You'll learn a whole lot more of failing than you do succeed if you don't challenge yourself now. You really got to question whether or not if you've already succeeded in everything and you've never failed, then how are you challenging yourself? Make it hard for yourself.
Yeah. Final question. What is your business's name?
Well, I have one called HvDonPresnell Agency. That's for Allstate. I have another one called TCG. That's the Collins Group. And I'm going to start another one soon, and I'll let you know what that one's going to be.
Okay. It was good to meet you.
Good to meet you as well. You're great, man. You're great. I like this kid. You had me you tough, man. You're tough. Tough. I like that.